Let's take a look at two different types of probability. We have experimental probability, like flipping a coin 100 times and recording the results, or theoretical probability, just thinking about what could happen if you were to flip a coin. What's the chance it would land on heads? Make sure you pause the video and record these definitions. Now, a key point here is that the more you perform an experiment, like flipping a coin, the closer you're going to get the experimental to become closer to the theoretical. So just flipping a coin 10 times isn't going to possibly get you very close to the theoretical, but if you flip that coin 1,000 times, you're going to become very close to the 50% chance of landing on heads. So let me show you how this works. Here I just flipped the coin only 10 times, and the results are it landed on heads 3 times and tails 7 times. So I'm going to look at the experimental probability of landing on heads 3 times. 3 out of 10 flips is 3/10, which is 30%. Now, theoretical, on the other hand, is not what happened at all in the event. It's just saying, let's just only look at that coin itself. There's 1 heads out of 2 sides to a coin. So it's 1/2 or 50%. And I would say the theoretical probability here is greater. So here we have, we're going to compare the theoretical and the experimental probability in this experiment. The results have been recorded. It landed on heads 6 times and tails 4 times. Pause the video and find both types of probability and then write a sentence comparing them. So the probability of landing on tails. It landed on tails 4 times out of 10, which is 4/10 or 40%. That's in the experiment. Theoretically, it would land on tails 1 out of 2 times, 1/2 or 50%. So the probability, the theoretical probability, is greater. Okay, here's another one to try. In this experiment, the coin was flipped 100 times. Let's look at the probability for tails. Pause the video and find both and compare them. So we're looking at the probability of it landing on tails. In the experiment, it landed on tails 60 times out of 100, which is 60%. But theoretically, we have nothing to do with the experiment. We're just looking at the coin. And there's 1 tail out of 2 sides, which is 50%. So our sentence, our statement, will be that the experimental probability is greater. In this experiment, the results from drawing a card 100 times are listed in the table. The cards are numbered from 1 through 10, and the number of times the card was drawn has been recorded on the table. So let's find and compare the experimental and theoretical probability of getting an even numbered card. Pause the video and try it. So the probability of getting an even numbered card in the experiment, we need to find all the even numbered cards. 2, 4, 6, 8, and 10 are even numbers. Find the sum of all those results and we get 54. That'd be 54 out of 100 times the cards were drawn, 54%. However, theoretically, we don't look at the results at all. We only look at the cards themselves right here. There are 10 cards, and 5 of them are even. 5 out of 10, 50%. And then we write a statement, and we say that the experimental, in this case, the experimental probability is greater than the theoretical probability.